Okay, so let's say you're given an equation, two variables, and I ask you, what is x, what is y here? What could you tell me? What could you tell me for values of x and y? It is, but there is possible values you can have for x and y, right? What would be one example?
1 and 0.
Well, 1 and 0 would equal 1.
1 and 1.
4 and 4.
Well, if I have x equals 4 and y equal to 4, technically that's not okay because if x equals 4, wherever there's going to be an x, there'll be a 4. So generally you don't want two variables to equal the same value.
2 and 6.
So okay, let's go 2 and 6. 2 and 6, and I like that, pick that right there, 2 and 6. Could I say something else here?
Yes.
1 and 7.
1 and 7. How far could we go on with this?
Not very far.
Forever, right? You can go on forever. You could even start using negatives and say, oh, -2 and 10. That would give me 8. So given this set of rules, these two variables, there isn't any way to determine which value or what is the value for each variable. But if I add another set of rules and say, well, if x plus y is equal 8, and I say, well, if you have x minus y, that's going to equal -4. Because I've set a second set or a second rule here with a second variable, it actually gives me the ability to start to determine what x and y are, because it's like they gave me one clue, well, x plus y is equal to 8. Well, this clue is not enough for me to figure out what each variable is going to be. But if they give me another clue, and now I can use this other clue to determine which each letter will be, right? And there's some ways to do that, okay? Some ways to do that. One thing we can look at is a method we call substitution, okay? Now, the reason we couldn't solve for this equation is because what? There's two what types of variables? Are they different or are they the same?
Different.
There's two different variables, right? But what's one thing I could do? Well, let me ask you this. What if I had 2x plus x is equal to 9? Could I solve for that?
Yes,
Why?
because you have the same variable.
It's the same variable. So one idea I can use or method is try to get this to be one variable. Okay? And what I can say is well, if I want to do substitution, okay, and I want to get basically one of these to be the same variable, well, let me get or figure out what is x going to be equal to. So if x minus y is equal to -4, what's one way I can get or figure out what x is? I can do what to x? I can
You can try to get it by itself.
get it by itself. And one way to do that is to move whatever's on the side of x to the other side. You do that with inverse operations. And I have x is equal to y minus 4. Now, if I know what x is equal to here, then I can use this y minus 4 to do what? I can use this in replace of what? In replace of what? What can I put this in replace of? What is this equal to?
X.
Is equal to x. So where I have an x, I can put a
Y minus 4.
y minus 4. So where I have the x plus y, let's just use the x plus y. And you can well, note important. If I've used this second equation to get x by itself, then I need to plug in to the first equation. And if I use the first equation to get a letter by itself, I'll need to plug into the second equation. So if I know what x is, x plus y equals 8. If I know what x is, in this case y minus 4, I can put that in for x. And now I have
The same variable.
same variable. 2y minus 4, I'm combining like terms here, is equal to 8. I'm going to add 4 both sides. 2y is equal to 12, divide by 2, y is equal to 6. Now, just trace back a little bit. We got a letter by itself, and what do? We got a letter by itself, and we substitute it. So, here, do we have a letter by itself equal to something here?
Yes.
Yeah, so can we substitute one more time? Of course. So we could say, okay, now where's the best place if I have y and I'm solving for x, where's the best place to plug in? For me, I think the fastest way is to plug in where I've already gotten x by itself. I can plug into here and here, but then I'll have to move pieces and get x by itself. Here I already have x by itself, so I could say x is equal to y, which is 6, minus 4, x is equal to 2. And here I have both values, and because this is a system, and we're talking about a system of 2 equations, which can be considered somewhat of a graph, because you're talking about values of y and values of x, I'm going to make this a coordinate, an x and y coordinate. I'm going to make this as a system, because this is what that is. That is a system of letters, and a y and an x. Now, if I look back here and I say, oh, let me check some of my work, does that make sense? Well, yes, 2 plus 6 is 8, and 2 minus 6 is also negative 4. So because I was given that second clue, I was able to use the additional information to get the value of both letters, plug in and check, and it works. Now let's use the same system, but let's use a different method here, but with the same goal in mind. So you have x plus y is equal to 8, and you have x minus y is equal to negative 4. Same system. What was our goal when we worked substitution? The goal was to do what? Or let's say, what was the goal here?
To figure out the value for the variable.
And we were able to do that because why? You're able to get an equation with one variable. Okay? That's the same thing I want to do here. My goal here is, okay, if I can eliminate one variable and just get it down to 1, now I can solve. This is set up nice because when I work in columns, basically you look at elimination like you're adding columns here. X plus x is 2x. The plus y and the minus y, you're adding the systems together basically, cancel out. 8 minus 4 is 4, divide by 2, x is equal to 2. Right? I've just eliminated the y's. This is my favorite method, elimination. I've eliminated the y's and just left myself with the x. Now you'll see some eliminations you'll actually have to put a number here or a negative sign to change the way these look in order to eliminate, but this is your basic idea of getting a plus y and a negative y to eliminate. Now once I've gotten one letter by itself, well then I can always just spin it around. 2 plus y is equal to 8, and I can plug back into either one. Either one will work. In this case, I can plug back into either one and get y is equal to, well, this was an 8 here, y is equal to 6. And what you notice is that this method gave me the same result as what I originally had using my substitution method. Okay? This is our elimination method right here. Our elim, we'll call it. Now, what last one you can look at is a graphing method. If you're stuck here and this doesn't work, and you're on an SAT, this is like a fail-safe. I feel like graphing something at the end of the day, if you can't solve it, graphing something, looking on a graph, putting it into the system, a system of x and y, I feel like you can always get closer to a result. Now, we have our x plus y is equal to 6. We have our x minus y is equal to -4. But I remember for graphing, and we've gone over quite a bit, the most important piece of graphing is my y equals mx plus b, my slope-intercept form. And in this case, in order to get slope-intercept form, like we've been doing this whole time, again, it's the idea of getting a letter by itself. I have a negative x. Oh, this is an 8. I keep making it a 6. Plus 8. I'll get x by itself, or y by itself here. Negative y is equals to negative x minus 4. Remember, it's y equals mx plus b, not negative y equals mx plus b. So these signs are going to change here. Positive y, positive x, positive 4. And then some of the information we get from that now, our slope-intercept forms, is that we have a slope of -1 and a y-intercept of 8. Here we have a slope of +1 and a y-intercept of 4. Now remember, this -1 can become a -1/1, which is down 1 over, and this here can become a 1/1, which is positive up 1 and over 1. So let's graph that and see what happens. Let's put some, I know I'm going to need 8, so I'll just put my 8 slashes here, or enough to have 8. Let me put like 6 here, a couple slashes. And I'm working with 1, 2, 3, 4, 5, 6, 7, 8. I'm going down 1 over 1, down 1 over 1, down 1 over 1. I like to use, when I'm graphing, I like to use at least like 4 points if I'm using a slope. 3 or 4, because it just gives me a much more accurate line. It kind of helps me guide myself to make a good line here. And then I'm going up 4, here's my y-intercept 4. I'm going up 1 over 1, up 1 over 1, up 1 over 1. And what do you guys notice that just happened here? What do you guys just notice that happened here?
They intersected.
They intersected. Does anybody know anything about how these look though, looking back on some other lessons?
Somewhat 90-degree angle.
90-degree angle, perpendicular, the slopes are negative reciprocals. That's really good that you guys caught on to that. Yeah, these are perpendicular slopes, and their intersection, what's a good color I can make pop here? Their intersection here is the point at which both values fit our original equation here and here. It's where both values fit our equation. Now guess what our coordinate is there? For x is 2, for y is 6. And that's why I was showing you guys these coordinates here, that 2 and 6. Over here, the 2 and 6. And you see when you graph, and you put this together, 2 and 6. Now obviously you guys seen one play, right? So this is not just going to magically happen when you see it. Each problem is going to be a little different. Things will get to be a little bit more, a few more steps involved to get a little bit more intensive. But remember, when you do, hard work makes things easy. So a little bit of practice should make this easy. But there's 3 ways you can solve each equation. 3 ways.